We are continuing with chapter 9 today. Today is day 2. It's all about substitution. So yesterday we talked about how to solve systems by graphing. You graph the two lines, you see where they intersect. Today we're not going to do graphing. We're going to learn another method called the substitution method. And then later this week we'll learn a third method, all of which can be used to solve the same type of problem. Any questions before we get going? All right, here is part A. So your notes have a little more information than mine do, so we can read through the steps. So the steps say to solve one equation for a variable, which as 1 or negative 1 as the which as 1. I think that should say which has 1 or negative 1 as the coefficient. So the first thing you want to do is get one of the variables by itself. Okay? Then you substitute that value into the other equation. Find the new equation. And then place the value found from step 3 into either of the original equations to solve for the other variable. So, step 1. Get a variable by itself. Do we have a variable by itself already? Yeah. Do you see how this y is already by itself? That's good. Put a box around what y equals. Y equals 2x. Now, I'm going to plug that in for the y in the other equation. So y and 2x are the same thing. Take the y out of the second equation, plug in a 2x. So I'm going to rewrite that second equation, no more y, put the x value in instead, the 2x in instead. Once you've substituted that value in, you should either have all x's or all y's. Once you get down to just one variable, you can solve that equation. So I do 5 times 2x, that gives me the 10x. Combine like terms. That's 12x equals negative 12. And what is x going to equal?
Negative 1.
Negative 1. Very good. Now, you want to take the negative 1 for the x and plug it back into either of the original equations. Which one looks easier? Yeah, I always, for substitution, plug it back in to the one that already had the other variable isolated. Okay, so once you get one of the variables, that means that the other variable should have already been by itself somewhere in the process. That's where I plug it back in. Okay? So y equals 2 times negative 1. What's 2 times negative 1? Negative 2. That's my answer. Negative 1, negative 2. Now, if you would have graphed these lines, you should get that same solution. No matter which method you use to solve these, you should be getting the same ordered pair. Yes, ma'am?
So negative 1, negative, that's where they intersect?
Yeah, so if I graphed these, the lines would be crossing at negative 1, negative 2. Yep. And if I plug in negative 1, negative 2 to these equations, I should get a true statement on both. Like negative 1 equals 2 times, or sorry, negative 2 equals 2 times negative 1, that's true. Here we get negative 2 plus negative 10, which is negative 12. So yeah, it does check out. Other questions? All right, here's B. All right, so do you see a variable that we could very easily get by itself?
Or y?
I think the x right here would be pretty simple, right? So I'm going to get that x by itself. I'm going to do that by subtracting 3y. All right, so now I'm going to plug 7 minus 3y into the other equation for the x. At this point, you should have one variable. We have only y's. All right, when you distribute the 2, and that's a big mistake here. People will put it in for the x, but they won't use parentheses, or they will use parentheses, but they'll only multiply the first term by it. So make sure that you're multiplying everything that's part of that x value, the 7 minus 3y, by the 2, okay? So distribute the 2, and now just solve this equation. So combine your like terms. They're both negative, so add them, keep the negative sign. What would I do next? Subtract 14 from both sides. Negative 6 minus 14 is negative 20. Divide by negative 10. So what is y going to equal? Y equals 2. Questions on the y? All right. So over here, do you see how x is already isolated? This is where I would plug in the y. Okay? You could plug it in here if you want. You could plug it in here if you want. I would plug it in here because x is already by itself. All right? So you just have to do 7 minus 3 times 2. Well, 3 times 2 is 6, and 7 minus 6 is 1. So my answer is the ordered pair, 1, 2. You should be writing these as ordered pairs, not just as an x equals and a y equals. Questions? All right, so I want to start by getting one of the variables alone. You can see that the s is the only one without a coefficient, the first s, so I'm going to get this one by itself. How would I get this s by itself? Add 4p. Good. And we've gotten kind of in the habit of putting the variables first because of y equals mx plus b. So if you have 4p plus 8, that's fine. It's just kind of sometimes happens on its own without even thinking about it. All right, so now we're going to plug this value in for the s where? In the other equation. So 2 parentheses, our new value. When you distribute the 2, you get 16 plus 8p minus 4p equals 6. Then what? Combine like terms. Subtract 16. Divide by 4. Negative 10 over 4 is negative 5 over 2. We just reduce the fraction. Do not make it a mixed number. Now I'm going to plug that back in to find the s. Okay? So up here, s is already isolated. So I can just plug it in and use the order of operations on the right side to simplify. So 8 plus 4p, but now p is negative 5 halves. What's 4 times negative 5 halves?
Negative 20 halves.
What is it?
It's negative 20 halves.
Negative 20 halves, which is negative 10. So 8 minus 10, which is negative 2. Now, anytime you're working with variables that aren't x's and y's, we go by alphabetical order, so P comes before S. So when you write it as an ordered pair, put P first and S second, okay? If you want to change them to X and Y at the beginning, you can. If you're more comfortable with X's and Y's, sure. Any questions? All right, here's the next one. All right, what do I do? Yeah, I think the second Y is going to be the easiest. Now, if you did one of the other variables, you should still get the same answer as us. So if you want to give it a shot and compare, that is fine by me. But I am going to go ahead and just get that Y by itself. So when I subtract 4x from both sides, I have Y equals 5 minus 4x. This is one where it would definitely just feel to me like I should do negative 4x plus 5. It would just happen naturally. I wouldn't even think about it. But this is obviously a pre-made PowerPoint, and that's the way it was. So either way is fine. Now, you want to plug it in for the y in the other equation. So this came from the second equation. I'm going to plug it back into the first. All right, distribute the 2. You get 10 minus 8x equals negative 3x. Then what? Add 8x to both sides. Divide both sides by 5, and we come up with the x value of 2. Now, y is already isolated over here, so let's just plug the x in and simplify. So it's going to be 5 minus 4 times 2. 4 times 2 is 8, and 5 minus 8 is negative 3. So we have our answer as the ordered pair 2, negative 3.
I plugged the y back into the 2y.
Did you still get the same answer? Sounds good.
Can I do that though?
Uh-huh.
Okay.
So her question was that she put it up into this y. No, right here, right? Yeah, you should be getting the same answer, whether you plug it in here, here, or where the y is by itself. They should all give you the same value. If they don't, you've made a mistake. You're plugging in the wrong number. All right, questions? Next. All right, how am I going to get A by itself? Plus 5B, good. So 10 plus 5B. Then what? Plug it into the other equation. So 2 and then parentheses. 5 plus B. And then continue on with the rest of the equation. Minus 10B equals 20. From here, I multiply through by the 2. So 20 plus 10b minus 10b equals 20. Uh-oh, what happens? The b's go to 0, right? 10 minus 10 is 0, so 10b minus 10b is 0 b's. 20 equals 20. You need to ask yourself, is this true or not true? This is true. 20 does always equal 20. So the answer is all ordered pairs on the line. If you graph these two lines, you would end up with two lines that are right on top of each other. So basically, any ordered pair that's a solution to one of the equations is also a solution for the other equation. These would be the same line right on top of itself if I graphed. What are your questions? All right, here's E. F. All right, what should I do? Sure, let's get the x by itself. So we can subtract y from both sides. So x equals 6 minus y. Then what? Put it into the other equation for the x. So 3 times 6 minus y plus y equals 15. When you distribute the 3, you get 18 minus 3y plus y equals 15. Then what? Subtract 18. Divide by -2. So y equals 3/2. Then what? Plug it back in. Good. I'm going to plug it in for the spot where x is already isolated. So 6 minus 3/2. You need to get common denominators. So to get common denominators, you would multiply the 6 over 1 by 2 over 2, right? So this would be like 12 over 2 minus 3 over 2, which is 9 over 2. That's where this answer came from, okay? Don't forget what you already know about fractions. So your answer here is 9/2, 3/2. What are your questions? What did we learn about today? Did I get you guys? The word problems are tomorrow. I was just watching you all panic as you kept flipping and checking and checking and checking. All right, what did we learn about today?
Solving systems with substitution.
Solving systems with substitution. That's a mouthful, right? Solving systems substitution. All right, here comes your homework.